So our lesson today is going to be based on the first of our Combinatorics unit. This is what we're going to be doing with our Binomial Theorem. Calculus students, you've already seen this in calculus class, but this is new to some and a great review for everybody. So I've got multiple monitors going on here as I try to record all of this. Let's just see what we can do. So we're going to begin by talking about Pascal's triangle. Which is the triangle 1, 1, 1, 2, 1, 1, 3, 3, 1. To reduce each row, of course, all we're going to do is just add on the next row by, starting with the 1. Take our 1 and our 3 in the row above and add them together to create the 4. The 3 and the 3 make a 6, and then a 4, and then a 1, always just adding diagonally from above. So Pascal's triangle, what's really interesting about it is that it's used in so many different applications. And the one that I would like to talk to you about today is expanding a binomial. So interestingly enough, I can look at the following pattern. I'm going to take an a plus a b as a binomial. I'm going to raise it to different powers. Power of 1, of 2, of 3, and so on. I'm choosing these very, very simple ones because they are ones which pretty much all of us can do in our head at this point in the game. A plus b to the power of 1 is just a plus b. A plus b squared multiplied by itself gives me an a squared, 2b, ab, and a b squared, but add in the coefficient. And in fact, what I could do is I could add in coefficients for everything, which will begin to very, very apparently show us exactly what's happening here. Our third row is going to be equal to, well, over here on the side, I'm just going to write out what a plus b cubed is. We all know that it's the same thing as an a plus b squared times an a plus b. An a plus b squared is an a squared plus 2ab plus b squared. And when I multiply that by an a plus b, I get everything in the first trinomial gets multiplied by the a. And then everything in the first trinomial gets multiplied by the b. Plus 2ab times b is 2ab squared. And b squared times b is b cubed, which then ends up giving me a cubed a 3a squared b, a 3ab squared, and a b cubed. Again, an a cubed, a 3a squared b, 3 ab squared, and a b cubed. Let's put in our coefficients. And as we've discussed, I think that's more than readily apparent that we're creating Pascal's triangle as far as the coefficients go. The other thing that we would want to look at is what's happening with our variables. So if I was to try and do an a plus b to the power of 4, I'm going to know that first of all, my numbers are going to go 1, just adding again the diagonal coefficients. 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and a 1. My a variable, or the portion in front of the binomial, starts with the highest power, a to the 4, and proceeds downward, descending in power, a cubed, a squared, a, and technically a to the 0, but we wouldn't show that. My b power, or my second part of my binomial, goes exactly opposite. B to the 4, b to the 3, b squared, and b. And then, of course, I just add them all together. So in a sense, that creates a formula that we'll be able to work with as far as creating, expanding any type of binomial like this. So what I'm going to try and demonstrate is this exact same one again, but without a's and b's, something different in place. So we're going to take 2x minus 3 and look at how to raise it to the power of 4. The first thing I'm going to do is I'm going to write down my coefficients. Being in the 4th row of Pascal's triangle, I'm going to have a 1, a 4, a 6, a 4, and a 1. I like doing these vertically and then putting them all together as a result. And the reason I do this is because of spacing. It will help matters later on. In the same way that up in my last row right here, I took a look at the a's going to the power of 4, power of 3, power of 2, and so on. Over in this new row, I'm going to take my 2x's, and they are going to go to the power of 4, of 3, of 2, 1. And again, technically is 0, but I'm just not going to show it. I'll show it this time. But of course, it's going to get canceled out because anything to the power of 0 is just 1. And my back piece, which here is a negative 3, is going to start at the power of 0 and then have a 1, 2, a 3, and a 4. And then what I'm going to do is I'm going to put it all together. I'm going to add them all vertically. So in my first row, this is the one that I'm looking at right now, I'm going to end up with a 1, 2 to the power of 4 is 16, negative 3 to the power of 0 is 1, and x to the power of 4 is x to the power of 4. My next column, I've got a 4, 2 cubed is 8, Negative 3 to the power of 1 is a negative 3. And x cubed is just x cubed. You can already see where spacing is an issue. I'm just going to move this over slightly. My next column, I've got a 6. I've got a 2 squared is 4. I've got a negative 3 squared is 9. And I've got an x squared. My next column, I've got a 4. 2 to the power of 1 is 2. A negative 3 cubed is a negative 27. X. And then in my final column, I've got a 1 and a negative 3 to the power of 4, which is an 81, which then ultimately gives me, putting it all together, 16x to the 4. There's a minus sign in the next one, so it's going to be minus 4 times 8 times 3 is 96, x cubed. 6 times 4 times 9 is a positive 216x squared. I've got a minus 216x, and I've got a plus 81, which I would argue is far faster to be able to put it together than anything that we would be able to do by expanding it by hand. So I'm going to write down my next example. And for those of you watching this as a video, I'm going to pause for a few moments. I'm going to ask you to try it yourself by pausing the video. And then after you have a solution, you can press start again. Go ahead. So I'm going to be putting this together with, again, Pascal's triangle. This time I'm being raised to the power of 5, so I need the 5th row of Pascal's triangle. So to be able to figure that out quickly, very often what I do on the side is I just jot down Pascal's triangle. It's fairly quickly to create. I don't have every single row memorized. I literally add the pieces together as I'm going through it. And then I'm going to take this row right here, my 5th row, and I'm going to use it to be able to do my expansion. So I've got a 1, 5, 10, 10, 5, 1. My piece in the front, which here is just an x, is going to go, change the color, x to the 5, to the 4, 3, 2, and 1. And my piece at the back, the negative 2, is going to go negative 2 to the power of 0, and then count up by powers. Which then ultimately gives me x to the 5, negative 2 times 5 in the next column is negative 10, x to the 4. Negative 2 squared is 4 times 10 is plus 40, x cubed. Negative 2 cubed is negative 8 times 10 is negative 80, x squared. Negative 2 to the 4 is 16 times 5 is 80, x. And negative 2 to the 5 is a negative 32. A nice quickly expanded binomial. And I think that's what we're going to call it for today. There is another formula as well that we can use, but all I want you to do for now is one question. this is just the way we're kind of getting started. I'm going to be able to touch base with everybody this way, and then we'll find out how you're doing. We'll take a 3x minus 2y. I'm going to raise it to the power of 4. And literally, that's it. Give it a try. I'll be in touch with you soon.